In every earthquake, there are buildings that are not ideal and yet they survive. What we're talking about here is making the best building we can. We have to. There's no alternative. We need to use the best details, in this case, the best connections between bars possible.
What we're testing is a reinforced concrete core wall, which is what will help hold up many buildings mid to high rise during an earthquake, resisting those lateral motions. What we've built here is a traditional technique of making one of these walls, and that uses lap splices, which is where two pieces of steel are overlapped and just laid next to each other, and then the concrete that's cast around them holds that splice together. It's not the only option. You can have mechanical coupling, or you can even weld steel together.
I've been doing research on this for about 12 years, 13 years, after going to Chile in 2010, where I saw a lot of these overlaps that had failed, like this one. And in this particular case, the wall is essentially disconnected from its foundation. That's not how we meant buildings like this to work.
We've been testing for about 3 days now, and you can see the damage that's accumulated on our wall here. Each one of these cracks is something that I've been keeping track of and marking as they develop with a black line. I mark when the crack forms with a number and how wide it is on pages there, and that's telling me how the wall is being damaged as I push it as if it was in an earthquake.
This technique has been used for a very long time, I believe almost up to a century, and we've seen most of our buildings have stood up really well with using this technique, including in the Christchurch earthquakes. However, we're always looking to improve. We always want more and more safe buildings if we can achieve them. So this is about just gathering that information and making better decisions for the future.
We need to understand how splices behave because there are decades of existing buildings that have walls built in this manner. But then we also need to look forward to the future. How do we build better buildings for the next generation?